Today I'm going to talk to you about advanced Swift command line applications. I'm going to talk to you about how you can actually use first-party Apple frameworks directly from the terminal. And I'm going to talk about very specific examples. So I'm going to talk about MusicKit and how you can use it in a command line application. And that requires something that most people don't know how to do, and I didn't know before I made this talk, which is giving your command line tool a bundle identifier. So I'm going to show you how you can actually do that. I'm also going to show you some styling libraries, so you can make with very, very minimal effort, you can make your command line application stand out. I'm also going to show you how you can parse arguments using Swift features only and using property wrappers, and how you can also read user input from the command line, so how you can prompt your users for input and just perform some actions based on that input as well. And finally, I'm going to show you some more advanced use case where you can actually show SwiftUI views directly from the command line, how you can launch an application and how your use case can actually scale from a tiny application in the command line to a full-blown SwiftUI macOS app without actually having to change the call site for your users. And as I said, I'm going to show you a very specific example, something that I've been working on recently. I've joined Hidom making Now Playing, and I've been using MusicKit a lot. And I've actually been working on a feature for app clips as well. And to generate app clips, the most common way is through an app clip code generator from the command line. And I wanted to access song information, such as ISRC codes or IDs, directly from the command line while I was doing my app clips. So I made a pretty complex command line tool to do that. And what I'm going to show to you today is a very slim version of that, a very slimmed down version of that and simplified version of that, because I learned a lot along the way, and I just thought I would dump it all in a talk and show you all some advanced use cases. And you might be wondering now, this person is talking about tools, and he's talking about developer tools and command line scripts. Why would you actually build it with Swift? There's so many good options out there, maybe more mature ecosystems. There's Bash, there's Ruby, there's JavaScript. But today and over the past few years, I've actually been advocating for making developer tools with Swift. And there's a bunch of reasons why you might want to make command line tools and why you might want to make developer tools with Swift. One of the reasons is that Swift has a very low memory footprint. What this means is you can run applications made with Swift in a wide variety of systems with very different specifications. It uses very, very little memory. It's got a very mature ecosystem, and it's got a very good developer experience as well. It's got a great open source community behind it, so much so that you can actually now make command line applications that not only run on macOS, but they run on Linux, and they also run, believe it or not, on Windows. I've had Swift command line applications running on Windows. It's a bit painful, but it's doable. This is also a statically typed language. What this means is that the compiler will actually catch a bunch of stuff before you run the application, unlike other languages. So some actual runtime errors result in compiler errors in Swift, which is great. It's becoming very, very slowly and gradually, it's becoming safely concurrent. So what this means is that you are able to manage different threads and concurrency very, very easily. So the advantages of async await for structured concurrency, the introductions of actors and sendable make it super, super easy to manage different environments and manage memory safety through concurrency as well. And finally, and this is what I say in every talk that I do about this, the most important thing is that it's a familiar language to you as an iOS or a macOS developer. And if you're working in a team and you're building a tool that's going to be used, built, and maintained by your Swift developers, it makes a lot of sense to make it in a language that you're familiar with as well. It's going to help you further down the line. It's going to help you with onboarding. It's going to help you with maintaining the tool. If something breaks, no one needs to learn Python or Bash to actually fix it. You can actually, develop it in Xcode, write some unit tests. So yeah, you can basically do it in a language that you're familiar with. So now that we know why it might be a good idea to build your tools and executables with Swift, I'm going to show you how you can create an executable. So the first step, and what I would thoroughly recommend, is using Swift Package Manager. So you can just jump onto the terminal and run Swift package init with a type of executable, and this will create a very, very simple package.swift file and a folder structure for you. It will create a single target. You can give it a name, or it will just pick up the name from your directory, and it will create a single file under that sources directory that it's created along with the package.swift, and it will just show a small template like this that says print hello world. And the way you actually run this is you can go to the command line and you can just do Swift run, or you can double tap on the package.swift, and this will just generate an Xcode project for you that you can command R and you can run it, and your application will basically run. Now, this is not very useful, right? We don't want just a command line tool that prints hello world, so let's add our first command. And before I start any command line application, even if I don't read anything, I don't need to parse any arguments, the first thing I ever do is use the best library ever in terms of command line tools, which is the swift-argument-parser. It's an open source library made by Apple, and it makes it so much easier to actually structure your application. You can use async await, you can define multiple commands, and you can also like parse arguments from the command line very simply. You can make them type safe, and you can use property wrappers to just generate like little help snippets as well in case the users miss a certain parameter. How do you import this library? Very simple. In a Swift package, you just declare it as a dependency, and you add it as a dependency to your target. That's literally all you have to do. And then you can go back into your main.swift, and you can start writing some code that looks like this. So all you have to do to create an executable with argument parser is import the framework, and then you create a struct that's called MusiCLI, or that you give it the name of like whatever command you want to use. And you make it conform to async parsable command. You can also make it conform to parsable command if you don't need the async await code. But I actually need it, so I just used async parsable command. It will require you to provide an entry point. In this case, it's just a run method. And one thing that you actually need to do is decorate the struct with the @main operator. Now, before, the way executables work and the way the template works is it creates a main.swift file. This tells the Swift build system that that is the entry point of the application, and you can just write top-level code, basically. If you have a struct, the Swift build system can't figure it out, so you need to decorate it with this @main attribute. But if you do that, you might run into an issue. And the issue is that the file can't actually be called main, because then you have 2 entry points. So you can't define an entry point in an executable that runs top-level code. So you need to rename it. Otherwise, you will see an error like this, and you might be wondering, what have I done wrong? It's a bit of a cryptic error. They could give you a better description, but they just don't. So yeah, just go ahead, rename the file, and everything will be okay. So, as I said before, I'm going to be using MusicKit. So all I need to do, because I'm developing for macOS, and this is going to run on the macOS terminal, I literally can just import MusicKit without any dependencies. And then in my run command, if you've ever used MusicKit, you basically need to request authorization from the user to access either the media library or the MusicKit APIs. Even if your requests don't require going into the user library, you need to request for permissions for some reason. So yeah, you do that in this way. I'm not going to go into too much detail, but there's a small helper function that checks the authorization status, requests it if it needs it, and then holds the program execution and returns if it's not authorized, basically. So once you've done this, you can move on to the next thing. And what I wanted to do at this stage was to request for a user input. So I want them to give me a query that I can then use to search the music catalog API and show a list of songs, basically. That's all I wanted to do. So I can use the built-in readline operator, super simple to do. It returns an optional string, and you don't need to do any async await code, and you don't really need to use any closures or anything. You just call readline, and your execution will just hold in your program until the user hits enter, and they've entered like something that you can then use. I can then use this query to perform some MusicKit operations. So I can use async await, and I can do try as well, because the entry point is throwing. And I can iterate through the songs that this response returns, and I can just print some information about them. In this case, just title, artist, the album, and the genres directly from MusicKit. And if you run this, if I go to Xcode and I run this, and this is where we're going to run into the first problem, it will ask for permissions. It all looks okay. So I can just search for a song, in this case, just getting started. And you can see that I'm getting permission denied, even though I agreed to the permissions and I said okay. And I'm also getting told that it couldn't request a token because it's missing a bundle identifier. So if you've ever used MusicKit, you actually need to create, for it to work in your application, you need to create a bundle ID on App Store Connect, and you need to give it MusicKit capabilities as well, and that needs to match the bundle identifier from your application. So I created one in App Store Connect, and at this point I was like, where do I set my bundle identifier? This is a single file executable. How do you actually do this? So I was very ready to kind of like just give up, but I instead, and this is very like common with me, and I was glad to see that, mess around and find out, because that's exactly what I did here. I went into a rabbit hole and I started to just dig the internet for answers to see if this was actually possible. Turns out it's actually possible. What you need to do, there's a bit of a disclaimer to this. I added some slides last night. You'll see why in a second. But what I did in this point is just scrap the Swift package altogether, create an Xcode project with a command line tool, do the same steps that I did before. So just copy paste the code, rename the file from main.swift to an actual name so that the compiler wouldn't shout at me. Bring in all my dependencies through the Xcode project this time. And at this point, I created an info.pilis file. Same as you would do with an iOS or macOS application, but remember, we're doing an executable here, so it's just a single file. And I gave it a bundle name and a bundle identifier. Now, how do I tell my executable to use this bundle identifier and to use this info.plist? Well, it turns out there's a very, very hidden Xcode setting called create info.plist section in binary. So you can set that to yes, and it will set some linker flags that will basically add the bundle identifier to your application, and it will basically add a bunch of info.plist fields. So you also need to provide the info.plist file, so the path to the info.plist, and then you need to, I don't know if this is actually required, but I provided the product bundle identifier as well to match the one in my info.plist. I don't think this makes a difference for running it, but Xcode complains at you and gives you a warning if you don't do this, so I just, I said, okay, I'll just do it. Cool, so now we've run this again. We're gonna see a very, very similar thing again. We're gonna request for the song that we wanna search. Just gonna use the exact same query as before. And this time, there's no errors. We're gonna get all the information back. So we've tricked the executable into thinking it's an application, so it can actually make requests to MusicKit, and it has a bundle identifier that can talk to App Store Connect. It can find the capabilities for MusicKit, so it's allowed to retrieve tokens and stuff. So that's working, and this is exactly what I added last night. It turns out this is possible in Swift package as well. All you have to do, I had to dig through the Swift forums as well. I've left a link to on that slide as well. I don't want any credit for this. It was someone on the Swift forums that tracked down what the linker settings were for that specific Xcode build settings as well. So you need to do something like this, give it the path to the info.plist, and it will create a section on the binary that you can basically use. I tested it out yesterday night, way too late, way later than I want to admit. So yeah, you can do that and use a Swift package if you prefer doing that. And you might think this is a bit hacky. Would you actually ship something like that? Well, you'd be glad to know that Apple actually uses patterns that are similar to this. And I quickly realized, as I said before, I've been working a lot with app clips and MusicKit. And when I was downloading the app clip code generator from the app clip tools and resources, I realized something that made me a bit suspicious and made me want to investigate a bit. And that was that the app clip code generator is downloaded as a DMG rather than a single file. This is a bit of an unusual pattern to have like an install wizard on just a command line file or a single executable. So I kind of thought this might not be a single executable. It might just give the impression that it is. So I decided to go into the terminal and do a which command to find out the path to that app clip code generator. It turns out it was a symlink, so I went to show the original, and it's a full-blown bundle or macOS application. So it's got an info.plist, it's got frameworks, resources. So you can see that, it might take you a bit more like setup to ship it, but you can actually do some pretty cool things, and you can have command line tools masked as kind of like macOS applications. If you want to find out more about it, like Alex that shared an archive, or I don't know who it was that shared an archive documentation, there is some archive documentation as well about this, about how to add an info.plist to an executable. It took me way too long to actually find this, so I just wanted to make it available for people, and I'm probably going to write an article about this as well next week. But yeah, if you're like me and you're interested in these things, you can find out more about it in that link there. Awesome. So now that we've got it running and it's all building and we've gotten past the first hurdle, I wanted to show you how you can actually make some command line tools, and this command line tool specifically, look a bit nicer. And I'm going to show you the process and what it takes to actually style an application in the command line. It's not straightforward, but I'm going to show you how it actually works under the hood. And whenever I explain these things, I always like to put Astro, which is one of my favorite web frameworks, their tooling as an example, because I think it looks amazing, and they've put a lot of effort into this. So whenever you create an Astro project, this is what the command line tool looks like. It's got a lot of probably over-the-top animations, but it's got a lot of like cool stuff. It's got pickers, components. It's got text fields that have a bunch of placeholders, nice like spinners. So yeah, you get to pick like a bunch of things. And the good thing about this is that you don't really need to know much about Astro. It will guide you through the process, and it will do it also in a very nice way. Now, I started to dig into, their code is open source. I started to dig into what this like tool looked like and how they actually implemented it. And unsurprisingly, because it's all written in JavaScript and it's a web framework, I didn't understand the thing. So I just put it down to pure like wizardry, basically. I just thought it was, some hidden thing I would never understand and I would never be able to learn. And I was fine with that, I just wanted some like Swift packages or something to help me like make my tools a bit nicer. But then I decided to look into like some Swift tools that were similar and could be used as like building blocks for making command line tools that looked a bit like that. And I quickly understood that all of these libraries work under a very, very simple principle called ANSI escape sequences. Now, before you run away from this room, I'm not going to explain into too much detail about this. I'm just going to give you a glance at how it works, just so that you understand what I'm going to do in the next section. But ANSI escape sequences are basically just strings of characters that perform operations in the terminal. So they can change the background color of text, they can change the color of text, they can move the cursor around, and it's the way you style and you perform actions on a command line. They're available on Unix terminals, so what this means on any terminal in macOS and Linux. And if you're crazy enough to build things for Windows, they are available in terminals from Windows 10 onwards as well. So you might be happy to hear that as well. And if we look at an example, if we've got a Swift command line tool that just prints hello world, like that template that Swift generated for us, if by default it will just print hello world in the default text color of the terminal that you've got set up. But if we actually add some magic characters to the beginning of the string, I'm not going to go into too much detail about this, but if you add some characters like this, that's the command for making things red. So any text that comes after that command will be red. And you can basically tack on operators and commands, so you can add another command to make the text bold, so that will basically make the text bold. And you might be thinking now, and very rightly so as well, who's crazy enough to do this and to look at this? If you actually were to do this with strings, your office might look a bit like this, if you're printing out like the commands and you look at the tables and stuff. But yeah, thankfully some people have gone through the pain of making like nice abstractions and Swift packages that we can use so that it's not as hard to actually style command lines. One of my favorite ones, again, great quote there, don't do it yourself, is ANSI Terminal by Pagleva. And this is one of my favorite packages that allows you to do things like this. So instead of writing weird characters, we can literally just import the Swift package, import ANSI Terminal, and then we can just stack on string extensions. So we can just do .red if we want to make the text red, and .bold if we want to make it bold. And we can change the commands. They return strings with all those characters in it. And it just works pretty good. And it takes very, very little effort to do things. One thing you actually need to consider is that if you run this in Xcode, you will see a bunch of like characters for all your escape sequences, and you won't see the text color. Before you lose your mind, like I did, you have to be aware that the terminal, the console in Xcode, is not actually a Unix terminal. It's just a console. So it will print the text as it is. It won't format it, and it won't respond to any ANSI escape sequences. And as someone probably famous or some iOS developers said once, it's not Xcode. Sorry, it's not you. It's Xcode. So yeah, make sure you actually run it in the terminal, and you will actually see the ANSI escape sequences there. So now that we know how it actually works, I'm going to show you how I styled the application that I made for the command line. One of the things that I very, very quickly notice is that if MusicKit doesn't have a certain request for a certain query saved, it can take a long time to actually make that request. And I wasn't relaying any information to the users. I wasn't telling them that something was loading, so to them it might look like it was hanging, basically. So I decided to go away and look for like spinner libraries or progress bars that I could directly like use in my project with just a few lines of code. And I bumped into this spinner library, which looks pretty cool. It's very similar to a JavaScript library called Aura, which basically uses Braille Unicode. It's a pretty cool use case. It uses Braille Unicode characters to generate spinners that basically move around in the terminal. So the way I used it was just import it into my Xcode project. You can import it into your Swift package, import it on my file, and it's literally as easy as just creating a spinner. You just create a class, give it the spinner type that you want. There's a ton of them. I just used the dots one. Give it the text that you want to display next to it, and give it a color as well. You can fully style it. You start it. The API is super simple. You start it. You wait for your operations to finish, so for the MusicKit request to finish, and then you stop it straight after, and it will basically just show a spinner in the terminal. I also used the library that I showed earlier to format my section where I print the songs a bit nicer. So I just made the titles bold by literally just importing ANSI terminal and tacking a dot bold to all of my strings, basically. So super, super simple. Within maybe 10 lines of code, we've got asynchronous operation, we've got terminal styling, and it takes very, very little effort. So this is what it looked like. So I went onto the terminal. Remember, don't do it in Xcode. And I just searched for a song. Let's dance to Joy Division in this case. You can see there's a spinner going on there, so we're relaying like some asynchronous operation is happening. And then you've got all the bold like titles as well, and you've got, it's a bit nicer to look at. Probably wouldn't win an Apple Design Award or anything, but it still looks all right. Cool. There's a lot of other libraries. There's a massive like Swift ecosystem. The community is absolutely amazing. There's projects like Awesome Swift that give you a bunch of Swift libraries and Swift packages that you can literally take a look at. It's great for inspiration on what to build next as well. There's a whole section on command line libraries as well. I'm going to leave a link to this, and I'm going to contribute this week with a bunch of libraries that I found so that the list is actually up to date. But I wanted to leave this section with a library that I came across. Actually, Leo Dion showed it to me a couple of weeks ago, which is called SwiftUI. Now, this is a bit crazy, but it's a narrow scoped like version of SwiftUI that you can use to write command line applications. So you've got things like state property wrappers, you've got vstacks, you've got for each, you've got buttons. I haven't actually tried it yet. I don't think I have quite the use case, but I'm eager for something to come up and actually try this out in production. Awesome. So let's now go through the last bit of the presentation. So I want to show you how you can actually go the extra mile. So if your use case actually grew into something where you needed to display information in an actual SwiftUI view, and your terminal actually didn't fit like the requirements of what you had to showcase, I'm going to show you how you can very, very easily show a SwiftUI view and display a window without actually having to make a full-blown macOS application. And while I'm doing this, I'm going to show you a very cool feature of swift-argument-parser as well, which allows you to structure your command line application into different commands. Super, super simple as well. So the first thing I did was to grab all the logic that I had on my MusiCLI struct, and I just moved it into its own separate command. So it's the exact same thing. It's literally just a copy-paste, and I renamed MusiCLI for search. So this is going to become my search command, the one that we've had until now. And then my MusiCLI struct, the one that's decorated with that main, literally just becomes still an async parsable command, but it becomes a configuration instead. So what this allows me to do is to provide a bunch of subcommands, in this case, only one, search, and I can give it a default subcommand as well. So whenever people run MusiCLI, they will run the search command. So they've got two options. They can run MusiCLI search or MusiCLI. So the default one will be search. So nothing changes in my user's call side, but I've restructured my application to make it look a bit nicer. So what this allows me to do is to create a brand new command called display. So this is what I'm going to use to kind of like just input a song, and the first result that I get back from MusicKit, I'm going to show the album art and the title in a brand new like SwiftUI window. So I've got the same thing, an async parsable command. In this case, I'm going to take in an argument from the command line. this is how easy it is. It used to be a pain to actually check the right type of the command line arguments in Swift. With argument parser, it's literally just a property wrapper. It formats, if you actually miss the required argument, it prints a formatted table with that like help bit you usually get in command lines completely for free. So yeah, you've got the song there, then you want to use this song parameter to actually run a music catalog search request in MusicKit. Same thing we did before, it just queries MusicKit for a list of songs matching the query string. Only difference is that we actually get the first result instead of showing the list. And a bit of cheating here, just to let the code like be very, very small. But all I did here was to call app.run. Now, this is a trick. This is all a lie because I made the app class to make it look nice and make it a one-liner. But the code is very, very simple. So I created a small wrapper which runs on the main actor. So it will always run on the main thread because it's UI code. Passed it the song. I created an app delegate. We'll see what the app delegate is in a second. And then I used AppKit code to basically run the application. So I just used nsApplication.shared, set a bunch of properties on it, and then I just run it. And what this app delegate looks like, you'll be very familiar if you've ever written any UIKit code or AppKit code and you've not used storyboards and you've done it from code. You literally just create a window, you pass it a content view controller. In this case, it's just a hosting controller with a SwiftUI view in it. You make it key, order it, and you make it order front so that it ignores every other application and it appears like in front of you. And that's literally all you have to do. And what the SwiftUI view looks like, it's not super important. It's very, very simple. It's got a color, which is the background color from the song artwork that comes back from MusicKit. And then it's got the album art, and it's got a title and a subtitle as well. And what this looks like is, oh, sorry, and I forgot, I actually have to add it back to the subcommands that we created earlier. So we only have search at the moment, but to make it available for our users, we need to add the display command there as well. I keep the default subcommand the same so that nothing really changes for anyone expecting, the search command to work out of the box. And whenever you run it from Xcode, one cool trick that I would suggest is to change your scheme to pass arguments on launch. So whenever we pass display and we give it a song title, you will see that it's launching a view. A SwiftUI view with the title of the song at the top, and then it's got the album art, the background color. So yeah, this kind of proves that you can scale your command line tools and you can start like very, very small, and you can make a macOS application without actually having to go through the trouble of all the SwiftUI views and stuff. You can make it like very, very simple. And you have to remember that a macOS application at the end of the day is literally just an executable. So this is basically how you can scale a command line application to display SwiftUI views too. If you are done with your application and you're basically ready to ship it, I would suggest you automate to automate the crap out of it. So yeah, I would suggest you ship it to places like Homebrew, make a GitHub release, and I would strongly encourage you to use like CI/CD for it. I've got an article on the topic if you want to learn about how to do that. But yeah, it will save you a lot of like time in the future as well. If you make a lot of command line applications, both at work or like personally, it takes just one setup to kind of like get it going, and then you can just duplicate that for every project that you have. And yeah, if you take one thing from this talk is that I would love to encourage all of you to build more Swift tools, basically. It makes a lot of sense if you're working in a team that's exclusively with Swift, or you're making an iOS application, macOS application, and you want to write a tool that accompanies it. Think about your future self and how thankful you're going to be to them if you build your stuff with Swift now. It's going to be so much easier to actually maintain it in the future. It's got a great ecosystem behind it as well, so you can piggyback off that. And you're going to have a lot more fun actually developing it. And all of this code is going to be open source for free. Don't take me on the quality of this code either. It was just a little command line tool. And remember that I've been packing a lot recently. I've not had a lot of time. So yeah, as the gift says, it may be garbage, but at least it's free garbage, So yeah, I'm going to share it on Slack as well. I'm going to open source the whole project as well, both the Xcode project and the Swift package. And yeah, this is where you can find me online. I've got also some stickers to give out. If anyone wants any stickers, just come up to me. And yeah, thanks so much for listening.
Right, questions. Since not all frameworks MusicKit are available on Linux, for example, how would I know whether my CLI, it's a good question, would compile for Linux, and how would I target another platform?
So unfortunately, all these frameworks are Apple frameworks, so you wouldn't be able to compile them for Linux. There is a new open source command line tool by the Swift server workgroup called Swiftly that allows you to basically install any tool change of Swift on Linux very, very easily. So if you're writing a command line tool, I would suggest just creating a CI/CD workflow that just checks whether it builds on Linux and runs the test on Linux as well. That will give you like an insight. Maybe you can set it up on every like push domain or something like that. I think there is a Swift package template by Matt MusicKit. I don't know if I'm pronouncing it right, but he's basically got a whole like CI/CD workflow that uses Swiftly out of the box, so you can like check that out and create the executable with that. So I would suggest running it on CI/CD is the best like bet you have to make sure it works.
Mm-hmm. Cool. What is your favorite football shirt?
So I'm a Barca fan, so I have to say one of the Barca ones, but my biggest like collection item is one Girona shirt, which is a Catalan team signed by the whole squad. Mm-hmm. So that has to be my favorite, okay. Like the one that, yeah.
But you bought the Leeds United jersey when you came here, right? The Leeds United one.
Oh yeah. That's my favorite now.
Right. Okay. We got. I mean, I'm just like the least football. I had a question, but I'm gonna skip to this one. Escape sequences, flashback 25 years.
Yes, unfortunately, still the way to do it.
I'm curious. So I also link some of your articles on my newsletter, mm-hmm. Because they're like, I would say different. You know, most people cover mm-hmm. all of these topics. So I'm curious why, why the interest in command line and using Swift, and I'm just interested what got you there.
Yeah, I get that a lot, to be honest. Like, I feel like I write about weird stuff, but it's just things that I keep doing on like my day-to-day, and I think part of what I was doing at my work really helped a lot because I was focusing a lot on like CI/CD and making a lot of tooling, and I've always been interested in that side of things, so that's what drove my like content creation a lot. And I always I might not write about like the latest things, but I always write about the things that I have struggled with the most, so that other people hopefully don't have to struggle as much as I did.
No, I mean, keep doing it. Because, I find it really interesting. Lots of Ruby Bash are just scripts in our repo. Does Swift have the same benefits if we replace that and run it with Swift Run?
So it really depends. I think the benefits, if that's something that you use internally in an iOS or like a macOS developer team, I would encourage you to do it because it's going to make it so much easier. Maybe in like 10 years from now, there's only one person that was there when they wrote the scripts, and everyone someone new has to actually learn, Bash or Ruby to actually work on those scripts. I know Fastlane is like big Ruby as well, so sometimes we can't avoid it. But yeah, if you can't avoid it, I would suggest try to rewrite them. I have worked in places before that to change one thing in like the metric system only used by internally by us. I had to touch 3 different languages. So I had to change some JavaScript and HTML mm-hmm. in the front end, some Python lambdas, some Bash scripts, and some Ruby code as well. Mm-hmm. And that was painful. So yeah, I would suggest use Swift as much as you can.
Yeah. I'm interested. Who is using Ruby as a scripting language? Yeah, interesting, because it seems to be the go-to, I would say, as a iOS or Swift developer, just because of the link between CocoaPods and
Fastlane,
and which is interesting. It's always me that ends up having to change the scripts at work.
I'm the same.
What is the name of the font used for the headings in your slides?
it's one of my favorite fonts. It's called Bricolage Grotesque, I think it's called. It's a Google font. I think it was made a Google font. If you Google it and make sure you go to the person who made it, to their website, because they've got a pretty cool story and the website looks absolutely amazing. So yeah, it's pretty cool font.
It's a Google font. Maybe we'll share it on Slack. Maybe, yeah. yeah. Last couple. So while we mainly use UI-based apps, do you know any practical example of a command line app or any big company that is using it? So yeah, any good examples?
So a few examples. One open source project that gave me the idea to showcase the SwiftUI view is Marin Todorov's Time UI. So that uses a very similar concept. You can time specific applications, and it shows like a UI as well. It launches an NS application, which is pretty cool. That's one use case. From places I've worked at before, at the BBC, we used a command line tool that ran on GitHub Actions to collect like metrics from our workflows and just push them onto our metric system and plot some nice graphs. So that's another like potential use case. Bootstrapping as well, for example, like if you need some bootstrapping for like your project, like download some dependencies or anything like that beforehand, you could just use a command line tool as well. But yeah.
Cool, great. Do you know if you can run, oh yeah, this is a good one. So GitHub Actions, can you run the scripts?
You can, yeah. So that's what's very big about compiling Swift on Linux and Swift executables on Linux. The prices for big, like large runners or runners on private repos, like Apple-based ones, macOS, they're very expensive. So if you can convert your tools into like Linux executables, you can literally run them on Ubuntu images. So they do run on GitHub Actions. If you drop me a message, I can like show you and ping you a few links to workflows that I have done in the past. And also the Swift package template has a great example. I'll share that as well with the slides. But has a great example of a workflow that compiles Swift to Linux as well with GitHub Actions.
Cool. And we've got Code Magic here.
That as well.
So that could be a good opportunity to sit with those guys. Favorite team?
Barca.
Yeah. I love how every talk references one hidden feature that is not documented by Apple. I mean, yeah.
I wouldn't say it's hidden. No. Say it's hard to find, which is a different thing. Maybe because of like it's not that wide a topic, it's more of a niche topic. I wouldn't say it's hidden. It's like the documentation is on archive. It's on the archive, which is a bit worrying, but still doable.
It's not the modern documentation.
No, it's not. It's
the legacy documentation. I mean, everything is documented, right? You know.
Yeah, it is documented, at least.
Yeah.
Kind of.
Okay, last one. Do we feel the need for a tool manager just for Swift CLI tools?
There is, and it's called Mint, I think. I don't know if anyone's used Mint before, but yeah, it's made by, I always get this wrong. I think it's made by John Sundell. I'm not 100% sure. It might not be. But yeah, if you Google Mint Swift Package Manager, you'll find it. It basically installs tools from like public GitHub repos that are Swift packages, and it builds them, and you can basically run them as executables.
Cool. Okay. Right. Shall we quickly run through these? Favorite CLI app?
Don't know.
Music.
Homebrew, probably. Homebrew. Yeah.
Homebrew.
Yeah. That opens the gate for a ton of CLI apps.
Do you add UI tests? If yes, how?
No. No. I don't even think I would add UI tests to my iOS apps. So yeah.
Yeah, that's fair. Right, amazing talk.
Thank you.
Big round of applause for Paul.
Thank you.